So today's lesson is all about absolute value equations. We recognize those symbol, the absolute value, those vertical bars means to take the positive. Absolute value means the distance between 0 and that number. As we look at absolute values, they act like a grouping symbol. So what we want to do is work inside the grouping symbol first and then take the absolute value of it. So these questions decide if the equation is true or false. I'll let you do those on your own for time's sake. Our goal today is to write and solve linear equations involving absolute values. We should be able to write two linear equations related to those absolute value equations, solve equations involving, we're just going to work on one absolute value today, and then we'll talk about the special cases, the special solutions, as we go through the lesson today or tomorrow. So our technical definition of absolute value is that a number's absolute value is its distance from 0 on a number line. And again, we write the absolute value with those vertical lines around a number. We can say the absolute value of 5 is 5, since the number 5 is 5 units away from 0 on the number line. 1, 2, 3, 4, 5. We also could say that the absolute value of negative 2 is positive 2, since negative 2 is 2 units away from 0 on the number line. That absolute value, that distance, is always represented as a positive in mathematics. So what we're going to do now is we're going to turn that around. Instead of saying what's the absolute value of negative 2 or what's the absolute value of 5, we're going to look for any values for x so that the absolute value of that number is equal to 3. What that means is on the number line, we're going to look for any values of x that are 3 units away from 0 on the number line. So here's 0, and I know that the number 3 is 3 units away from 0. So the absolute value of 3 is 3. 3 solves our equation. But there's another number also that is 3 units away from 0, and that's negative 3. There are two solutions to this equation, 3 and negative 3, and when we're solving, we like to say find the solution set. Sometimes you'll see those squiggly brackets around the numbers. I need you to find each value that solves the equation. So not just one of them, we need to find each of them to get a full solution. What if I asked you to find any solutions to the absolute value of x is equal to 0? Well, that's how many numbers are 0 units away from 0 on the number line. The only solution there is the number 0. So our solution set is just the number 0. What if I asked you to find any numbers that are negative 4 units away from 0 on the number line? So here's where we're going to get really technical. We could say negative 4 is negative 4 units away from 0, but we just said a minute ago, absolute value is always positive. Distance away is always positive. We always measure distance in a positive way. And because of that, we would say this equation has no solution. There is no value for x that will be negative 4 units away from 0 on the number line. That's one of those special cases, and we'll talk about those as we go. In general, here's what this looks like. If we say the absolute value of x is equal to c, is equal to some number, that equation is going to have two solutions if that number you're looking at is bigger than 0. Another way to say greater than 0 is positive. If this number is positive, you're generally going to have two solutions. If that number is equal to 0, it's only going to have one solution, because there's only one number that will be that far away from 0. If that equation is equal to a negative number, some number less than 0, then it will have no solutions at all. So our possibilities here are no solution, no solutions, one solution, or two solutions. That's it. Those are our only options for absolute value equation. So the ones we just looked at were about how far away from 0 on the number line. This one is asking about what are some numbers that solve this equation. Let's think this through. The absolute value of some number minus 4 is equal to 6. Well, if I think about plugging numbers in that are on this number line, can I find a number that when I substitute it in for x, I get a number equal to 6? Well, I think 10, if I substitute 10 into that equation, 10 minus 4 is 6. Its absolute value is 6. So 10 is part of my solution set. Is there another number? Well, let's see. We're looking at distance 6 units away from this number 4. 6 units away this way was 10. 6 units away this way is negative 2. So I have another number. Let's see. Negative 2 minus 4 is negative 6. And when I take its absolute value, I do get 6. So my solution set here, there's two numbers. And we said that a minute ago. The absolute value, if it's equal to a positive number, should have two different answers. So we can kind of check. I don't want to do that, though. Here's kind of what's happening here with that last problem. Our target value, we'll call it our target value, is 4, and we're looking for all numbers that are 6 units away from that target value. Find all the numbers so that the distance between those two numbers and 4 is 6 units. It's kind of what that looks like. Notice that we're talking about the distance between, and the distance between includes a minus sign there, right? The distance between 5 and 4 is 1 unit. The distance between 4 and 5 is 1 unit. I'm subtracting to find that distance. So what if I try same kind of thing here? I'm looking for numbers that are 3 units away from, but here's where I have to be careful. The distance between that number and x, that would be x minus, but it's a plus there, which means that my target value was a negative 1. X minus negative 1, which is x plus 1, should equal 3. So I'm going to watch that sign there. So my target value is negative 1, and I'm looking for numbers that are 3 units away from negative 1. So 1, 2, 3. X should equal 2, and 1, 2, 3. X should equal negative 4. And if I check those numbers in the original equation, negative 4 plus 1 is negative 3. Its absolute value is 3. 2 plus 1 is 3. Its absolute value is also 3. So we've got a target value and the distance away, and we kind of work our way on the number line. General rule, though, we don't want to always have to be guessing and checking here or drawing a number line. So what we do is we get a general pattern to solve this idea of the absolute value of x minus a equals c. That equation's going to be true when what's inside this absolute value bar, that x minus a, when it's equal to whatever that number is, c, or when it's equal to the opposite of whatever that number is, negative c. Then when I take its absolute value, I will get c. So what we do is we do this a lot in math. We're going to set up two cases. So what I'm going to do is take what's in here, x minus a, and I'm going to make it equal to c. Then I'm going to do same thing, and I'm going to make it equal to the opposite of c. So notice when we do that, we just get rid of the absolute value bars. I like to use those absolute value bars as reminders to me that there are two cases here. So I like to draw little lines like that. Our two cases in this number example are going to be take what's inside the absolute value, x minus 5.3. That's going to equal 7.2. That's my first case. And then my second case, x minus 5.3 equals negative 7.2. Now I just go ahead and solve those two cases. So I'm going to add 5.3 to both sides, plus 5.3. I get x equals 12.5 is one of my solutions. And then same thing here, what I have to be aware of course, is my signs. That's negative 7.2 plus 5.3 gives me x equals, I believe that's negative 1.9. So my solution set here, and again, you don't need to draw these squiggly brackets, but I have two different answers in my solution set. So our goal, again, is set up those two cases. And we'll take one more look here. What about if we have a longer equation? So I've got 2 times the absolute value of x minus 3 plus 5 equals 13. Tempted to distribute that 2 into the absolute value sign. Don't ever do that. Never distribute into an absolute value symbol. Weird things can happen. Just very strange things, especially if we distribute a negative sign. So don't do that. What we want to do is isolate the absolute value first. So just kind of pretend that we're getting this thing like it's almost like a variable by itself. Get it by itself before we do anything else. So I'm going to subtract 5 from both sides. That's 2 times the absolute value of x minus 3 equals 8. And then again, instead of distributing that absolute value, what I'm going to do is divide both sides by 2. And that's going to give me the absolute value of x minus 3 equals 4. And now that it's isolated, I can do what I did in the last screen, set up those two cases and solve. Okay, so isolate first, get that absolute value by itself. So I would do this, x minus 3 equals 4, and x minus 3 equals negative 4. And again, notice when I write those down, I'm not using the absolute value symbols anymore. It's just whatever's inside the absolute value. If it's equal to 4, we have a solution. If it's equal to negative 4, we have a solution. And if I add 3 to both sides, I get an x equals 7. And adding 3 to both sides here, I get x equals negative 1. So those are my two solutions. And we'll talk about the other cases, the special cases, and the absolute values on both sides tomorrow. Okay, hope that helps. Bye-bye.